Hello everyone, this is Abhijit Paradkar from Patukola College of Commerce and Management. Today we are going to discussing about Simplex Method. So, what is Simplex Method? Simplex Method is a iterative method to find optimal solution. So, in order to find optimal solution, we have to go by iteration to iteration. From one iteration to find better solution, we have to go for next iteration until the optimal solution is found. So, it is an iterative method. Graphical method is convenient to use when there is only two decision variable that we have already seen in previous lecture. That graphical method you can easily solve the linear programming problem having two decision variable using graphical method. But with the help of simplex method we can solve any linear programming problem with any number of decision variables so that it is advantage of using simplex method. You can deal with any decision variable. Simplex method attempts to move from one corner point of the solution to a better solution until the optimum is found. The algorithm is very efficient because it considers only those feasible solutions which are provided by the corner point. Moreover, not all corner points are evaluated in the solution procedure. However, computations are tedious, repetitive, and boring, right? So you have to do same tasks for repeatedly until the optimum solution is found. Now, general form of an LPP. Any linear programming problem can be converted into the general form. So let's say for n decision variable and m constant, assume that the same variables are, let's say, x1, x2, and so on xn. Then any problem can be converted into this general form. So objective functions either may be in terms of maximization types or minimization type. So z equals c1x1 plus c2x2 plus c3x3 plus and so on cn where c1, c2, c3 and so on cn are coefficient of objective function and x1, x2, x3 and so on xn are decision variable and subject to linear constant, that is a11x1 plus a12x2 plus and so on a1n xn, and in bracket I write the types of constant, that is may be possible. The constant may be less than or equals type, may be equals type, or may be greater than or equals type, and b1, b2 and so on bm are right hand side constant. So these are all linear constant, and a11, a12 and so on a1n, a21, a22 these are all coefficient of constant, and b1, b2 and so on bm are right hand side of constant, and this x1 comma x2 comma and so on xn greater than or equals 0 are non-negativity constant, which is very important in this problem. So this is general form of linear programming problem can be converted into this form. Now let's see one example. A furniture of manufacture two products, chair and table. Each unit of chair requires 2 kg of wood and 3 labor hours for producing, whereas each unit of table requires 3 kg of wood and 3 labor hours of same type. Every week The company has an availability of 60 kg of wood and 96 kg of labor hours. 1 unit of chair yields rupees 40 and 1 unit of table gives us rupees 35 as profit. Formulate this problem as linear programming problem to determine as how many units of each of products should be produced. Solution. So here, first of all, identify the types of objective function. So it is clearly indicates that objective functions is of maximization type. So maximize profit Z. Now identify decision variable. So here we have to take decision that how many units of chair and table we should produce. Achieve the maximum profit. So our decision variable are x1 equals number of units of chair to be produced and x2 equals number of units of table to be produced. So these are our two decision variables, and this is the objective functions, that is maximize z equals 40x1 plus 35x2, where 35 and 40 are profit coefficients and subject to linear constant. Here there are two constants. One is availability of woods and another one is availability of labor hours. So here 2x1 plus 3x2 less than or equals 60, that indicates the amount of wood, and the next constant is amount of labor hours. So per week company have 96 labor hours, whereas company has 60 kg of wood, right? So this is the formulation of linear programming problem. Any linear programming problem can be represented in this manner. Either it has objective function of maximization type or minimization type and subject to constraint. Now we see some assumptions in linear programming problems. Number 1, proportionality. It assumes that there is constant returns to scale and no economics of scale. If product of A contributes 10 rupees profit, then total contribution will be 10x1, where x1 is number of product A. So it is generally understood that as the number of production of product increases, the cost of particular product decreases. But here it is not like that. Here, if you produce 1 unit, if a 1 unit of product A contributes 10 rupees, so 10 units of product contributes 100 rupees. 100 rupees of products contributes 1000 rupees. So no price discounted here. Number 2, additivity. It implies that total of all activity is given by sum of profit contributed by each of the products separately. Similarly, amount of resources value used equal to the sum of the resources value used by various activities. No iteration between decision variable. Number 3, continuity. Decision variable are continuous as consequence combination of fractional value in the contents. The production problem are possible and obtained frequently. Thank you.